Okay, so in this video we will make the animation of phased array radar. So you can see this is the sample example of the phased array radar. So what it will have is, you can see, so it will have the one transmitting unit, and on the top of that it will have the number of individual small antenna nodes placed, and usually it will be placed in the certain number of columns and the rows, so in the 2D format, and each these individual nodes will have the phase shifter, means the propagation of the waves from these each individual nodes can be controlled by the phase shifter, and it will have the separate control mechanism it will do. So the meaning is that, so when you want to propagate the wave in the certain directions, you don't need to rotate this entire antenna to the particular direction. You just have to change the phase to these individual phase shifter, so that when the propagation of wave will happen, then it will bend to the particular direction, and this will happen when the superposition of the individual waves from each antenna will take place. So you can see when these antennas are propagating the wave, then this is the superposition angle for this antenna. So this animation we will try to plot into the JavaScript, and let's see. So already I have taken the folder, so let's add the HTML file. So I'll name it phased array radar.html, and I'll add the JavaScript also. So phased array radar chase. Okay, so in the HTML file we'll add the HTML tags. So we'll give the title, in the body we'll add the canvas element first, canvas id equals to canvas, and then we add the script tag. Type will give, then we want the source, we'll link this JavaScript file which we created to this. Yeah, so HTML part is done. Let's go to the JS file. So we'll take some constant values as a width of the canvas. Say I want 500 pixel. The height of the canvas, I want around 500 pixel. Then the canvas constant, so it will be document.getElement by id, and id name is canvas itself. Then context, this will be the comma here, so context equals to canvas.getContext, and it will be 2D. So we got this. So let's set the width and height of the canvas. So canvas.width equals to width, and canvas.height equals to height, what we have set. Then the background color of the canvas, I want in the black color, 000. So let's check if it is correct. We'll go to the HTML file and run this file in the browser. So we can go from here, open a live server. So yeah, so this is the canvas is ready now. So what we will do now, first I'll plot the base of the canvas here, and then in the top of this base I'll mount these individual antenna nodes. So let's do that. First I'll take the variable antenna underscore base, and this will be the object, and for this I want the x position starting from 0, then the y position, I want the total height of the canvas minus say 35 pixel, then the width, I want the entire canvas width, then the height of this antenna base, I want say 20 pixel. Okay, then it will have one function. I will write one function that is called draw base, This will be the function, and inside that we will draw the base. So we will write the context dot begin path, context dot fill style. I want in, say, S FEDCBA, then context dot fill rectangle rect, that will be the antenna base dot x, antenna base dot y, antenna base dot width, and antenna base dot h. Then we will context dot close path. Yeah, so this will draw the antenna base for me. So let's take the function draw phased array radar, and inside this we will call this antenna base dot draw base function, and below that we'll call the draw phased array radar function. So let's check if it is working fine. Yeah, so this is my base I have drawn. So on the top of that I want the antenna node. So I want this circle here point the certain number of circle, and then I'll connect with the base. So let's take the function for that. So below take the function called antenna node. So it will take the x, y, radius, and this each individual antenna will have some phase difference, right? So we'll take that also. So that's called the phase difference. Okay, so let's set the value x equal to x, this dot y equals to y, and this dot radius equals to radius, this dot phase difference equal to phase difference. And this will have one more property. So when you can see on this one individual antenna, when it is radiating the wave, so it will have one wave, two wave, three waves. So this is called the array of some radius, right? It is propagating. So we'll take that array. So I'll call this dot radius array. Okay, and let's set this current value, this dot radius array, and push. Will add the one value, say 12 pixel as of now. Okay, so let's get the draw function for this. So antenna node dot prototype dot draw node equals to function. Okay, and we'll draw here context dot begin path, context dot fill style. Say the node of this circle I want in the red color, so F00. Then context dot arc, since it will be the circular node, so I'll take the arc function, and the position will be this dot x, this dot y, this dot radius, and the starting angle 0, end angle 2 times pi dot pi. Okay, and then context dot fill and context dot close path. And I want to connect the when I'll draw the node at some above the height of this position, then I want to connect with this base also, right? So let's do that connection also. So we'll take the line for that. So context dot begin path, context dot stroke style. I want the same color what I have taken for the base, so it is FEDCBA. Then context dot line width, say I want 3 pixel. Then the context dot move to, it will move first to this dot x and this dot y. Then context dot line to, so it will connect to the this dot x. No, it will connect to the it will connect to the this dot x to the y position will be the y position of this base, right? And the y position of antenna base is already we have set here in this object, so it is antenna base dot y, and it is nothing but height minus 35. So we'll give that, so antenna base dot y, and the context dot a stroke to draw the line, and context dot close path. So it will draw the antenna node. So what we'll do, let's take the array variable where we'll store the individual antenna object. And so for that, first I need the one variable that is called the number of antenna node, how many antennas you want. So I will take that, currently 10 number of antennas I want. Okay, so now we'll take the variable called the antenna spacing, and it will be the total width of the canvas divided by the number of antenna nodes. So it means this is the maximum space we can give it between the each antenna, right? And let's take the another variable that is called the antenna and the array, and it is array. Okay, so this is done. So what we'll do, below this object I will call the I'll put the for loop to set the individual object of this one to this array. So for let I equals to 0, I is less than the number of antenna node, and I plus plus. Okay, so we'll add the antenna array dot push the new, and that will be the antenna node, this one. So we have to put the parameters. So the x position will be the I plus 1 times the spacing, antenna spacing here, this one. The y position, the y position will be and say it will be antenna base dot y, say some certain 20 pixel level. Then the radius will be say around 7 pixel, and the phase difference I want the I plus 1. Yeah, so done. So this array, the array is initialized. So let's draw the function. Let's draw this individual node. So I'll take the one more function here. Function draw all nodes, and then what we'll do, the antenna array we have dot for each, and we'll take the each element and we will draw that a dot draw node. I believe this is the same function and we have taken, yeah, so this draw same. So it will draw the function, and we'll call this function inside this draw phase radar function. So let's check if it is fine. Yeah, you can see, so I have the antenna placed. These are my nodes of the antenna, and this is the connections to that, and there is one separate antenna, so I don't want that. So what I'll do in the loop for loop, I'll just make these to -1. Since we start the count with the I plus 1, that is why we have that spacing. So I don't want the first and the last, this one and this one, so I want in the center. So yeah, this is my antenna now placed. So what it will do, this each individual antenna, it will radiate the wave, right? So let's get that function also. So we'll below what we'll do, so antenna node dot prototype dot radiate wave, and that will be the function, and it will do. So how it will do, so it will do for all the array what we have pushed here, right, inside this array, radius array. So what we will do, so on this dot radius array dot for each radius we will try to draw that. So let's take the r as a object here, and we will draw for that r. So here context dot begin path, context dot fill style, So it will be a since it will be the wave, so I don't want in the I want the circular path here, circular path. So it will be the stroke type, not the fill type. So stroke style, and the color, say I want 3df000. Then context dot stroke line, so otherwise line width we can take, line width equals to the 2, and the context dot arc, and we will draw this circle. So what we will do, so we want the position called this dot x, this dot y, and the radius will be the r, what we just got for the individual radius r. Then the starting angle, since we will draw the wave from this position to this position, right, like this I want to draw. So this will be the starting angle and this will be the finish angle. So it will be 0 comma map dot pi, not the 2 pi, I just want the half of the circle. And I want in the when you draw in this direction, then this is called the true, so it will be anti-clockwise, right, from here to this side. So this is anti-clockwise. If we take the false, then it will be this side, clockwise. So I don't want the clockwise, I want in the anti-clockwise. So I take the optional parameter, that is to true, and the context dot stroke, okay, and context dot close path. Okay, so this is done. So what we will do now, we will call this function for the animating, right? So let's take the function. I'll take the set interval. It will this interval we call after 10 millisecond, and this will be the our called function. Inside that, okay, so this is my this function I don't need now. So automatically this will be called every 10 milliseconds. So you can see this is being called every 10 milliseconds. You can see. Okay, so far so good. We will animate this. So what we will do is here we have the antenna node we are drawing, right? So let's create the function to radiate that. So here for each antenna node, draw node, then for below inside this loop for antenna node, sorry, antenna, this will be antenna array, right? So antenna array dot for each I want to draw the animation. So a dot radiate wave, this will be called, and it will radiate. So you can see this is since we have not put the we have not increased the radius, so that is why it is drawing at the same location. So what we'll do, let's create this separate function that is called function update radius. And what it will do is it will for all antenna array, and for each antenna node it will take the radius. So for let I equals to 0, I is less than the a dot radius array dot length, and I plus plus I want the let r equals to a dot radius array of I, then I will increment the r plus plus, then a dot radius array of I will set it back the r increment value. Okay, we'll check one more thing. We'll check if radius is greater than the width or height of the canvas, right? Then in this case no need to add the no need to keep this array. So why we want to simply increase the length of the array, right? So we will remove those elements from the array. So we'll check if a dot radius array radius array or radius array of otherwise we can check the r value, because we have the r we have set. So r is greater than the width or r is greater than the height. Then in this case we will remove the element, remove that r value, right? So radius array dot splice will remove that. So each at I index I want to remove the one element. So this is done. So let's call this function inside the loop function. So here we have set the node, we'll call this. So let's check how it is working. So you can see the wave is propagating. Since we didn't clear the canvas, we have the view like that. So let's clear the context dot clear it. So this will be 0, 0, width, height. So let's save and check. So you can see, yeah, so since it is I have only one radius, so it is propagating that radius. So what I will do now, since also you can see the animation, so it is taking entire half circle. So I don't want that, I want portion of that. So what I'll do inside the radiate function here, so I have taken the entire this one, right, half of that. So I'll start with some left side. So math.py by say around 6, and we'll add to this math.py by 6. So let's save and check how it is doing now. Yeah, you can see it is not taking the entire half circle, but instead some portion of that, right, of the graph. So fine. So we did. Now what we do, we want the number of wave pushed, that, right? So since we have only one, so after certain time interval we want to push the another wave, right? So what we'll do, I'll take the another set interval function below. So set interval, and I want the function, okay, and this will happen every say around 300 millisecond. Okay, and what this function will do is it will add the radius. So what to where, so what we'll do, antenna array dot for each, and we'll take the element node as a, and inside this we want to push. So a dot radius array dot push another 12 pixel array for a radius of 12, right? So you can see now after every 300 millisecond it is pushing the another radius, and it is propagating. So you can see when the radius is becoming more than the width or height of the canvas, then it is getting automatically removed from this radius array, right? So this is good. So now we want the delay into this node, right? So for that what we will do is inside this function, so we'll take one more parameter, say the phase, I call that the phase diff, and initially it will be 0. So every the 300 millisecond I will increment it by 1. Sorry, this will be the phase difference plus plus, and for each antenna node we'll check if a dot, so otherwise phase difference is equals to a dot phase difference, what we have said. If it is true, then for that phase difference we'll push that, right? So you can, we'll save this. Okay, so good. So you can see the first wave is getting propagated, because as soon as we are getting the object, already we are setting here, right, this one 12 pixels. So now I don't need this, because after a certain interval already I am adding the another 12 pixel radius. So now you can see it is propagating in certain delay. So what we can do, we can reduce the delay now, say around 100 millisecond. So yeah, so you can see this is the wave propagation now. And one more thing is, since again it is not adding the another, you can see it is adding only one, and again it is not adding. So what it is happening, because when we are incrementing the phase difference, we are not resetting it back to 0. So we'll check if phase difference is greater than or equal to the total number of antenna node. So why? Because since when we are setting when in the for loop, you can see here in this for loop, it can go up to the maximum of antenna node, right, to this number, because we have given I+1 the phase difference, so it can go maximum to this value. So from this, so the phase difference could be maximum of this one. Once it is reached, then again I want this set back to 0. So in this case, after this 100 millisecond, you can see it is adding. So this is the propagation of the phased array radar. So this is happening the right side. If you want into the left side, you will just put the difference, so that will be the current number of antenna node minus. So you can see now it will be propagating towards left. So yeah guys, this was the animation of the phased array radar. Thank you for watching this video.